Cardiac output is defined as the volume of blood ejected by the left ventricle per unit time. The volume of blood is called the stroke volume, and the unit used to measure cardiac output is 1 minute. So, cardiac output can be calculated as stroke volume, which is the volume of blood pumped out of the left ventricle per beat, times the number of heartbeats per minute, which is around 70. Another way to calculate cardiac output is by using the Fick principle, which simply states the oxygen going into an organ minus the oxygen left out of an organ must equal how much oxygen that organ has used. Using the Fick principle equation of cardiac output equals oxygen consumption divided by arteriovenous oxygen difference, cardiac output can be calculated. Both methods render normal cardiac output to around 5 liters per minute on average. To measure cardiac output, we first have to take a look at the left ventricle. There's a moment when the left ventricle is fully relaxed. It occurs at the end of filling or diastole, also called the end diastolic point, and the volume of blood within the left ventricle is called the end diastolic volume, and it's about 120 milliliters. Then the left ventricle contracts, forcing blood through the aorta and into the whole arterial system. After that is another moment when the left ventricle is fully contracted. It occurs at the end of contraction or systole, also called the end systolic point, and the volume of blood within the left ventricle is called end systolic volume, and it's about 50 milliliters. So end diastolic volume minus end systolic volume gives us the stroke volume, which is the volume of blood that the left ventricle ejects with every heartbeat, or stroke. In this case, the stroke volume is 120 minus 50, which equals 70 milliliters. Every minute, though, our heart beats about 70 times, on average. So, if we multiply the stroke volume times the heart rate, or times our heart beats per minute, we'll get the cardiac output, which is the total volume of blood that the left ventricle ejects in 1 minute. Using the stroke volume of 70 milliliters per beat, and a resting heart rate of 70 beats per minute, cardiac output is 4,900 milliliters a minute, or 4.9 liters per minute. Remember that a normal adult body contains approximately 5 liters of blood. So this means that every last drop of blood travels through the left ventricle at least once every minute. Another way to measure cardiac output, which does not involve using the stroke volume or heart rate, is called the Fick principle. The Fick principle simply states that at rest, the oxygen going into an organ minus the oxygen left out of an organ must equal how much oxygen that organ has used. Using the Fick principle equation of cardiac output equals oxygen consumption divided by arteriovenous oxygen difference, cardiac output can be calculated. By convention, the organ used for calculation is actually the body. So the Fick principle states that at rest, the oxygen in the pulmonary veins going to the body, full of oxygen, minus the oxygen left in the pulmonary arteries coming back from the body, or oxygen left after the body has used some, must equal how much oxygen the body has used. The Fick principle also makes the assumption that at rest, the cardiac output for the right and left ventricles are the same. Each of the parameters of the Fick principle can be measured. The oxygen content of the pulmonary venous blood can be measured by taking a sample from peripheral arterial blood, since none of the oxygen added by the lungs have been consumed at this stage. The oxygen content of the pulmonary arterial blood can be measured by taking a sample of mixed venous blood from the pulmonary artery or the right ventricle. The amount of oxygen in the pulmonary veins is equal to the pulmonary blood flow multiplied by the oxygen content of the pulmonary venous blood. Similarly, the amount of oxygen returned to the lungs via the pulmonary artery is pulmonary blood flow multiplied by the oxygen content of pulmonary arterial blood. Remember that pulmonary blood flow is the cardiac output of the right ventricle and is assumed to be equal to the cardiac output of the left ventricle. Expressing oxygen consumption mathematically, we get oxygen consumption of the body equals cardiac output multiplied by the concentration of oxygen in the pulmonary vein, minus cardiac output multiplied by the concentration of oxygen in the pulmonary artery. Solving for cardiac output, you get cardiac output equals oxygen consumption of the body divided by the oxygen concentration of the pulmonary vein, minus the oxygen concentration of the pulmonary artery. For an average 70-kilogram person, total body oxygen consumption is around 250 milliliters a minute at rest. Let's work through the problem together and calculate the cardiac output for a man lying in bed. This person has an oxygen consumption of 250 milliliters per minute, a femoral arterial oxygen content of 0.3 milliliters, and a pulmonary arterial oxygen content of 0.25 milliliters. What is his cardiac output? So remember, cardiac output equals oxygen consumption of the body divided by the oxygen concentration of the pulmonary vein minus the oxygen concentration of the pulmonary artery. So, plugging in numbers, we get cardiac output equals 250 milliliters per minute divided by 0.3 milliliters minus 0.25 milliliters equals 5,000 milliliters per minute, which equals 5 liters per minute. The Fick principle is not only good for calculating cardiac output, it can also calculate blood flow for individual organs. For example, renal blood flow can be calculated by dividing oxygen consumption of the kidneys by the difference in oxygen content of the renal arterial blood and renal venous blood. Alright, as a quick recap, cardiac output can be measured either as the stroke volume times heart rate or with the Fick principle. The Fick principle assumes two things while in the steady state. First, that oxygen in the pulmonary veins going to the body minus the oxygen left in the pulmonary arteries coming back from the body must equal how much oxygen the body has used. Secondly, that the cardiac output for the right and left ventricles are the same. Using the Fick principle, cardiac output can be calculated by dividing the oxygen consumption of the body by the difference in oxygen content of the pulmonary veins and pulmonary arteries.